This lesson's on vectors. A lot of times when we're using different types of measurement, we can use things like temperature or distance or area or velocity or acceleration. What I've done here is put these into two different groups because there's a big difference between these types of measurements. Over here, these types of measurements are represented by a real number, what we're going to call a scalar. And that means it has a magnitude or just a size. So like, a number like 3 or 5 or 6. Down here with these types of measurements, we've got force, velocity, and acceleration. They're a little different. They also have a magnitude or a size, but they also have a direction that goes along with that. And that's what's going to be represented by vectors. Alright, so we've got this line segment, PQ. We'll call it a directed line segment because it's pointing in some direction. And here we have our initial point P and our terminal point Q. The initial point is where it starts, and Q is the terminal point because the line segment terminates or ends at Q. So PQ with the little lines around it over here, that represents the length of the magnitude of this directed line segment PQ. And the direction is from P to Q. If you write it like that, we got from P to Q. So if you were to write it like this, QP, it would be from Q to P. And note that whether it's PQ or QP, it's still going to have the same length, but if we write it as QP, it's going to be the opposite direction of PQ. So here's just some important things to note along with this. So if we've got two directed line segments, if they both have the same length and direction, then they're going to be equivalent. And the set of all directed line segments equivalent to PQ is the vector V. So this is where we're officially kind of defining the term vector. So, and we'll label that as just a bold V, and it's equal to PQ. Next thing is only direction and magnitude matter when we're talking about vectors, so it doesn't matter where the location of the vector is on the coordinate plane, it's just the direction and magnitude. We can denote these vectors with lowercase letters, so you get a U, V, W. It really doesn't matter which ones you choose. A lot of times in a textbook you'll see them as a bold lowercase letter, and I've seen them before sometimes with the lowercase, the little line over it, so just pay attention to the way it's denoted. So two vectors are equal if their corresponding directed line segments are equivalent. And to make that a little more clear, I'm going to show you a quick example. Okay, so on this coordinate plane here we've got directed line segment RS, and we can call that one vector U, and here we've got OP, and we'll call that one vector V. And this question asks us to prove that U and V, or the vector U is equivalent to the vector V. So to do that, we're going to need to show that they're the same length or magnitude, and also we want to look at the direction. So let's do the magnitude first. Magnitude of RS is, we'll just do our distance formula over here. So put these points in. We've got -1 minus -4 all squared. 6 minus 2 squared comes out to be 5. We'll do the same thing over here for OP. Put the points in over here. We've got 3 minus 0 and 4 minus 0. It's just going to end up being 3 squared plus 4 squared under the square root. That's going to give us 5 as well. So they are the same magnitude. Now looking at the direction, we can do this by looking at the slope. If they have the same slope, they're going to be pointing in the same direction. So let's look at the slope of RS. It comes out to be 4/3, and the slope of OP comes to be 4/3 as well. Since we have the same slope, we have the same direction, and since we have the same magnitude, well, since those are equal, we have the same magnitude. So we've shown that with magnitude in the direction that those are in fact equal.